Hello, my name is Lillian Wilson-Wade, and this is the first Physics 2 lab examining charge tapes. The purpose of this lab was to determine how much excess charge was present on one piece of charge tape. By doing this, we become familiar with charge and its effects on everyday objects and their interactions. I found that one piece of clear charge tape had an excess charge of 1.54 times 10 to the negative 8 coulombs. Before getting further into this lab, let's take a minute to review the fundamental physics concepts one needs to understand to complete this lab. I utilize Coulomb's law, which indicates that opposite forces attract and like forces repel. I also use these formulas to calculate the electric field and gravitational force on an object. This lab also included an application of Newton's second law. In this experiment, several assumptions were made to approximately determine the amount of charge on the floating tape. I ignored air resistance on the moving object. I treated the U-tape as though it were a point charge with all the charge concentrated at the center of the long tape in order to simplify calculations. I also assumed that the net charge was the same amongst all U-tapes because we did the same steps and methods to charge all tapes used. Now to get into the observations found upon conducting this lab. I found that the U-tape was attracted to neutral objects like my hand or a book. When two U-tapes were placed near each other, they repelled, which indicated that they had the same charge. To determine whether that charge was positive or negative, I held a U-tape near a negatively charged pen. I observed that the U-tape was weakly attracted to that pen, which indicated that the tape had a positive charge. When we attempted to float one U-tape above another, we found that the top tape, tape B, began to float when tape A was 2.5 centimeters or 0.025 meters away. Here are my calculations. I first measured the length and mass of my U-tape. I calculated the force of gravity on my U-tape by multiplying its mass by negative 9.81. Then I set this force equal to the electric force to isolate and solve for Q, the charge. Next, I found the number of electrons on tape B by dividing the charge Q by the absolute value of an electron's charge. I then found the ratio of deficient electrons to atoms. I did this by dividing the number of deficient electrons by the total number of atoms on the tape. I found the total number of atoms on the tape by dividing its area by the area of one atom. So you can see that my ratio of deficient electrons to atoms is for every one electron, there's about 7.26 times 10 to the 8 atoms. I have about 9.6 times 10 to the 10 electrons deficient on my tape. And like I said earlier, the charge on the tape I found to be 1.54 times 10 to the negative 8 coulombs. Finally, let's take a look at my computational model. We were tasked to produce a model of two charged tapes exerting an electric force on each other and experiencing a gravitational force. We were to use this model to estimate the amount of charge on each tape necessary to float one tape above the other. So you can see that I've modeled tape A and tape B as the blue and red orbs or spheres. The electric force of tape A on tape B is modeled as a purple arrow pointing upwards. The gravitational force on the two tapes is modeled as the yellow arrow pointing downwards, and the electric force of tape A on tape B is modeled as the green arrow pointing downwards. So now just a few additional questions to answer. So what if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tapes and other charged objects? So nothing would change. The behaviors would stay the same, but with the opposite sign. Like charges would still repel each other, and opposite signs would still attract. Why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or with other objects? So it's important to handle the charged tapes as little as possible because we want them to remain charged. Once the charged tape touches a neutral object, electrons move from the charged tape to the neutral object, which neutralizes the charged object. So thank you so much for listening, and I look forward to completing Lab 2.